The next section is how to interpret some of these complex diagrams. In some cases, the answers that you get might not make sense, so that's why it's important not to assume certain things. When you look at this picture here, we can assume that J to G is a straight line, okay? But we can't assume that H to L cuts it directly in half. We don't know that. Unless we start to solve things. We can assume that we have things like supplementary angles and complementary angles, but we don't know. And so that's why it's important to not just say, oh, these ones have to be 90 degrees, and draw it on your picture. Unless you actually know it and you're given it to you. So very important that do not take a picture for what it's worth, but go ahead and assume only certain things, like the fact that J to G is a straight line, or the fact that most of these are going to be straight lines as well. Okay. Anything that looks the same, you have to actually show with numbers that they are the same. Okay. Unlike this picture, because you have two intersecting segments, you can assume that you have some equal stuff here, like vertical angles. Like I could assume that this angle and this angle are going to be the same because they are vertical of one another. I can assume that this one and this one are the same because they are vertical of one another. Okay. I can assume that these two add up to 180, or these two add up to 180. There's a lot of things that you can assume in a picture like this. Let's try example 3. Let's see what we're given. Determine whether each statement can be assumed from the picture and explain. So CF and CE are opposite rays. So yes, opposite rays means you have a straight line. So CF and CE look as if they create a straight line. Okay. Let's look at C. It says that ABJ, I'm going to go ahead and mark it on the paper. ABJ and CBG are vertical angles. You can assume that these are vertical angles because there's two intersecting lines here. There's this one and this one. So you can assume the two angles that are embedded in there are the same as well. BCG, let's mark it. BCG, that's this one. And DCF are congruent. So that one would be a no, because you can tell that those two pieces are not intersecting at the right spots. Okay. In order to get them to be the same, the dot would have to be right there. I'm going to erase the picture for the next one so that we can start from clean scratch here. Let's see what the next one is. BE and IF are perpendicular. So let's see. BE and IF are perpendicular. This one's a really common one that I think that people mess up. My first instinct would be no. Let's see what they say. Yeah, there's not enough information. They look like they make a 90 degrees, but unless you have anything else on the picture, you can't assume it. You can't assume something is a specific measure. You can assume that an angle and another angle are congruent. You just don't know what the number is. In this case, we can't just put a number on a graph. It could be 91 degrees and look really, really close. So yeah, you just don't want to assume things like that. Okay, let's do a couple more here. E, B, C, and C, B, G, B, C are complementary. E, B, C, C, B, G. Same thing. I'd be hesitant to call anything complementary because you're saying that it adds up to 90. And there's a huge difference in two angles adding up to 90, knowing that it creates that 90-degree angle. If something is creating a straight line, that's different. Okay. Something can look straight, but something can't look 90. Okay. So that one would be a no. There's not enough. All right, let's do H, and that's where we'll end on this video. So BC is the angle bisector of ECG. So basically what we're saying is that this angle here, or this ray, cuts this one in half perfectly. Same thing. Unless you have some numbers or symbols in here to say that those are the same, you can't assume it. So that one would also be a no.